Okay, guys. Today, I'd like to explain about derivative and differential. So, the basic rule of derivative or differential is if y is equal to ax to the power of n, so dy over dx is a multiplied by n x n to the power of n minus 1. So for example, if we have 2x to the power of 3, uh, y to x to the power of 3, dy over dx is 2 multiplied by 3x to the power of 3 minus 1. So 6x to the power of 2. And then if y is equal to 2x to the power of minus 1, dy over dx is 2 multiplied by minus 1x to the power of minus 2. So minus 2x to the power of minus 2. So it means uh, it's same with minus 2 over x squared. And the other example is y is equal to root 3x. Yeah, so the dy over dx is same with 3x to the power of half. So dy over dx is half 3x to the power of, I mean, not that. Sorry. Is 3x to the power of half. So dy over dx is, is 2 complicated. So for example, y is equal to root x. So dy over dx is half x to the power of minus half. So it's, yeah, something like that. Okay, and then uh, for example, we have y over y is equal to ln x. So it is the special rule of uh, derivative or differential. So dy over dx is 1 over x. So if you have y is equal to ln x, dy over dx is 1 over x. And then if you have y is equal to fx to the power of n, so dy over dx is n fx to the power of n minus 1 multiplied by f, multiplied by dfx over dx. Yeah. So if you have, for example, if you have y is equal to 2x to the power of 2 plus 3x plus 5 square. So dy over dx is 2x to the power of 2 plus 3x plus 5 to the power of 1. And then dfx over dx is the derivative of this. this term. So 4x plus 3. So the result is 8x plus 6. So 2 multiplied by this, and then 2x squared plus 3x plus 5. Okay. And then, for example, if you have root 3x squared plus 7x plus 8, which is the same with 3x squared plus 7x plus 8 to the power of half. So dy over dx is half 3x squared uh, 3x squared plus 7x plus 8 to the power of minus half multiplied by the derivative of this. So 6x plus 7. Yep. Okay, and then so the result is 6x plus 7 to root 3x squared plus 7x plus 8. Okay. And then if you have y is equal to ln 3x squared plus 7x plus 5, so dy over dx is remember that if you have y is ln x, ln x, so dy over dx is 1 over x. So in this term, if you have y is equal to ln 3x squared plus 7x plus 5, dy over dx is firstly you get 1 over 3x squared plus 7x plus 5, but you have to derive the function in the ln form. I mean, you will get 6x plus 7, which is the derivative of this term. So the result is 6x plus 7 over 3x squared plus 7x plus 5. Yeah, it's like something like that. Okay. And then what's the economic implication of the derivative? So if you have total revenue is 7q squared minus 56q plus 5. So your if you are asked about average revenue, so average revenue is TR minus Q, over Q, I mean. So AR is 7Q squared minus 56Q plus 5 over Q. Yeah, so the result is 7Q minus 56 plus 5 over Q. But if you are asked about marginal revenue is the first derivative of total revenue function. So total marginal revenue is dTR over dQ. So it means that marginal revenue is 14Q minus 56. So it is the marginal revenue function. And then in economics, in mathematics, there is a multiplication rule of derivative. There are other name. There is another name about multiplication rule, but I'm used to using multiplication rule name for this rule. So if you have, for example, if you have y is equal to 4x plus 3 squared and something like that. Okay, so firstly you can separate this and this. Suppose this is u and this is v. So y is equal to u multiplied by v. So if you have u multiplied by v, dy over dx is the first derivative of u multiplied by v plus v prime multiplied by u. I mean. So dy over dx is 2 4x plus 3, yeah, and then multiplied by 4. You have to remember this. We have to derive 4x plus 3, the first derivative of 4x plus 3. Multiplied by v. V is this. So root 4x squared plus 5x plus 6 plus first and then v prime is this is same way. So the first derivative is half 4x squared plus 5x plus 6 to the power of minus half and multiplied by 8x plus 5, something like that. So the result is 8 4x plus 3, 4x squared plus 5x plus 6 to the power of half plus 8x plus 5 2 root 4x squared plus 5x plus 6. Okay. And then this is multiplication rule. And the rule is, the name is division rule. So in division rule, for example, if you have y is equal to 3x plus 5 over something like that. So you can change this to u and this to v. So you have u is 3x plus 5 and then v is root of 4x plus 8. So is equal to 4x plus 8 to the power of half. And then if you have y is equal to u over v, dy over dx is u prime v minus v prime u over v squared. So dy over dx is u prime is 3 and then multiplied by 4x plus 8 minus v prime is half 4x plus 8 to the power of minus half, u is 3x plus 5 over v squared. V squared is this square 4x plus 8, something like that. Okay, this is the answer. Yeah, you can make this to the more easier term. I mean more easier equation, but yeah, it's like this. And then the important things in derivative and differential is about partial derivative. What is partial derivative? Suppose if you have v equal to 3x plus 5xy plus 6x squared y plus 7y plus 5. The partial derivative is d, for example, d do. So it's not d but do because d is for total differential or total derivative, and then do is for partial derivative. So suppose do z over do x, yeah. So it means that you have to derive z with respect to x, and other uh, let other variable is constant. Yeah, we have to recall something from this. Suppose if you have z equal to 6, so dz over dx is 0, of course, something like that. So if you have, but if you have z is equal to 7x, because 6 is constant, 6 is constant, 6 is constant. So if you have z is equal to 7x, so dz over dx is 7, but dz over dy is 0 because there is no y in this term. So if you have dz over dy, you can you can mm, you can apply that 7x is constant. Yeah, because you you want to derive dz with respect to y, something like that. So if suppose so we can derive this dz over dx. So dz over dx is 3 plus, yeah, 5y, yeah, because 5y is constant and you have x to the power of 1, so x is uh, we can delete x and then plus 12xy, yeah, plus 0 plus 0. Because this is constant, this is constant. But if you want to derive dz, I mean, you want to derive z to the power, you want to derive z with respect to y, you can get something like this. 3x is constant plus 5x plus 6x squared. Yeah, because this is constant. Plus 7 plus 0. Nah, this is the result. So it's easy. It is the partial derivative. So, for example, suppose if you have y is to the y is equal to k to the power of 1 over 3, l to the power of 2 over 3. Yeah, something like this is the production function with two inputs. So if you are asked about marginal productivity of k, yeah, marginal productivity of k is do y over do k. Yeah, because you are asked about k. So we have to derive y with respect to k. So the result is 1 over 3k to the power of minus 1 over 3, and let L as constant. So L to the power of 2 over 3. And we know that this is more than 0 because, yeah, there are no minus in this term. And in the what's that? In the coefficient. And then what is marginal productivity of labor? Marginal productivity of labor is dy over dl. So 2 over 3k to the power of 1 over 3 l to the power of minus 1 over 3. Yeah, and this is more than 0 too. But you can get the second derivative of this term. I mean the y, the second derivative, mpkk. So it means that it measures the change of mpk. So mpkk is the change of mpk if you add one more k. So it's equal to do mpk over do k. So the result is minus, I mean, it's not k to minus, it's 2 over 3. And because 1 over 3 minus 3 over 3, it's minus 2 over 3. So, which, where is, so minus 2 over 3 multiplied by 1 over 3, k to the power of minus 5 over 3, L to the power of 2 over 3, which is less than 0 because there is minus. And MPLL is do MPL over do L, which is minus 1 over 3 multiplied by 2 over 3, k to the power of 1 over 3, L to the power of minus 4 over 3, which is less than 0. So in this term, you know that MPK and MPL is more than 0, but MPKK, the change of MPK is less than 0, the change of MPL also less than 0. So it describes about the diminishing return of marginal productivity of input. Yeah, this is the law of diminishing return of marginal productivity of input. Yeah, so if you know about that, this is how to derive the marginal diminishing of productivity, the diminishing return of marginal productivity of input. Okay, the last but not least things that I want to explain is about the chain rule. So in derivative, in the differential, there is the chain rule. What is the chain rule? Suppose if you have something like this, LT is equal to L0 e to the power of nt. This is L is labor. Labor is the function of L0. The labor is in time 0. And E is exponential term to the power of nt. N is growth of population, and t is time. And you have at is a0 is multiplied by e to the power of gt. At is technological progress. Technological progress is the function of a0, which is technological in time 0, and e to the power of gt. So if you want to know in this term, what is the growth of LT? So you want to get the growth of LT, you can you have to find this. This is same with growth of L. So you can use chain rule to find this. How to derive this? So first time you have to transform this equation to log form. Yeah, there is something that I have described in the first meeting, in the first session of this tutorial. So uh, you have to change this to the log form, and you have learn LT is equal to learn L0 plus learn e to the power of n t. So and then after you get this, you can change this. Learn LT is learn L0 plus this is NT to the power of learn E. Learn E is 1. Learn E is 1. Yeah. Learn T is 1. Learn E is 1. So learn LT is learn L0 plus plus NT. Nah, and then after that, you have to derive this with respect to T. Yeah, derive with respect to T. So you can get the ln LT over do T is equal to ln L0 over do T plus N. And then you can get ln L, you can use chain rule to derive this. So ln LT over do T is equal to ln LT over do LT do LT over do T. Yeah, you can cancel out this, but uh, we need this term to derive this is chain rule. So it's equal to do ln L0 over do L0 do L0 over do T plus N. So do ln LT over do LT is equal to 1 over LT, and do LT over do T is same with L T dot. Yeah, you can write like this, and then for this is L. Yeah, but this term is 0. Yeah, because the L in time 0 is we can assume it 0, so plus N. So you can get that L dot over L is equal to N. So the growth rate of populate the growth rate of labor is equal to N in the economy. In the economy. So with this way, yeah, with this rule, you also can get the growth rate of the technological progress, which is A dot over A, and it is equal to G. Yeah, because it is this. It has the same pattern. Okay, I think it's enough for today. If you have any question, you can ask after that in group or in uh, my YouTube channel. Thank you, everybody, for joining us.